into a neural net sort of form. So not the traditional things you normally see with neural networks for categorization and learning and training, but just I'm trying to use this neural network as a way of encoding things like a piece of music. One thing they showed, or showed you all sorts of various different signals, but one of the things they showed was you can use this to generate 3D forms, three-dimensional 3D geometry. In particular, there's a way of representing three-dimensional geometry they're called sign distance fields, where basically you've got almost like a value at every point in space that maybe is almost like negative if you're inside the object, positive if it's outside the object, and zero, almost like where you want the surface of the object to be. And it's trying to take something like point cloud data and turn that into a sign distance field is actually generally a really quite difficult thing to do. And people have used neural nets for it. And this is them comparing, sort of Sitzman comparing using a rectified linear unit, was like the most traditional neural net, trying to do this problem of turning a point cloud into a sign distance field. And it's sort of like fine details all missing, it's all a bit noisy and things. Doing it with these sirens, these periodic functions, it actually captures a lot of really good sharp detail. It's got, you know, much smoother, it's much better representation of, so it's almost like doing things like, let's take a 3D scan of a room, point cloud, how do I turn that point cloud data into geometry? Things like these sirens are potentially like a really good way of doing that. So you can generate three-dimensional geometry with sirens. Now I'm going to take a sort of a sideways leap from that. Okay, frequency and phase modulation. This is almost like the synthesizers of the 1980s, particularly things like the Yamaha DX7. So the idea from the audio synthesis, almost like the most traditional audio synthesis, is just like adding together a few oscillators, called Fourier synthesis. But if instead of adding together, you feed one into each other, so it's almost like using the output of one oscillator to modify the values going into the next oscillator, you can end up with much richer sort of complex waveforms. So this is showing, actually this could be either what's called frequency modulation or phase modulation synthesis. For just doing two, they're basically the same. But basically, if I've just got two different oscillators of different frequencies, you can get a huge range of all sorts of different waveforms. So this is just showing, you know, what happens if you have, you know, a low frequency waveform feeding into a high frequency one is the first one. This is about two, but about the same frequency, or one is a high frequency one feeding into a low frequency one. You get this really quite rich palette of possibilities, even just with two sort of like oscillators, right? So basically the idea of frequency modulation and phase modulation is you can produce this really rich set of outputs, but generally the curse of them was they're really difficult to program. It's really difficult often to work out how to make them do a specific piece or sound, right? But you know, few like parameters to twiddle with, and it produces quite crazy, interesting range of possibilities. Well, one thing is actually when you look at these sirens, and well, how they actually work is basically saying all these like neurons feeding into each other. It basically is phase modulation synthesis. Right? So because basically, you know, you take each layer, you know, there's like all these inputs, multiply them by the weight values for different inputs, and then you take the sign of that. Actually, that's effectively phase modulation synthesis if what's called the carrier was very low frequency, almost like, you know, really, really low frequency compared with the input. It's almost saying that the sirens are a neural net take on effectively phase modulation synthesis, what I was sort of saying. So, hey, okay, this is me thinking like, okay, phase modulation synthesis can produce all sorts of crazy sounds like the Yamaha DX7, and sirens can produce shapes and 3D geometry. Okay, this sounds fun. Okay, what can we do with this? Let's experiment with this. So, guess this is, I come to my stuff. Okay, synthesizing quasi-periodic forms. So I say it's almost like taking these sort of phase modulation ideas, was classic, almost out of control. I like things that are a bit out of control. All right, so almost out of control audio synthesis. But let's use it to generate 3D geometry instead of sound. So basically, obviously, this is the same diagram I've had for the sirens. So basically, technically how I sort of set it up. As I said, it's more about this in the paper and things like that, but briefly, Basically, if you just take almost like an input to this neural net of just like the X, Y, and Z positions in space, and then you have a few layers of these sort of sinusoidal operators, neurons, and then output of almost like a single value. Basically, you can use that as a, say, 3D field. So say like, negative values are inside, positive values outside, and what I'm interested in is the surface of values at 0. And then what I was wanting to do is like, okay, what Vincent Sitzman and all showed is if you've got a sufficiently big neural network, you can sort of generate anything. But okay, if we use a really quite small neural networks, let's just find out what was like the natural palette of expression that these sort of these sirens have. So actually have some relatively small numbers of neurons, and treating this of output as a 3D field, and then let's generate the ISO surface, almost like the contour where the values are 0. And that produces things like this. So basically, how I'm turning that into rendering is I'm just sampling it as voxels, so just basically a regular point, almost like the points in a cubic grid. Generating triangles using what's called March cubes. That's about the most traditional computer graphics algorithm for turning a field into a surface. And then rendering that using NVIDIA's optics library, which is basically a library for running on the GPU so I can actually render things with ray tracing on the GPU. And I guess the cool thing is all those three things, they can all be run massively in parallel, really quite easy to program on the GPU. So I can run this whole thing on the GPU, which means hopefully I can also do it really efficiently. So this is actually a video running from real time on my computer. So this is it's a relatively low resolution grid, but actually it's 2 million voxels being generated so it's generating this field values from the siren, creating the triangles, rendering them with self-shadowing, all happening in real time. Right? So cool. It's actually really, it's real time. Hey, I can now start playing with this, try different values and things like that. So I've now then took this into what's called Species Explorer, which, if you know my other stuff, I do a lot of sort of generative creating, often biologically inspired stuff. But I've created this interface for myself that allows me to combine using things like genetic algorithms and machine learning and other sort of forms of random sampling and things like that, basically just to explore. I've got something that's generating things based on a set of parameters, and I want to try and find the parameter values where hopefully interesting stuff happens. So I basically got a few parameters for almost saying how I generate the siren networks, and then I've been using my Species Explorer software to just hopefully find some interesting sets of sirens. So what am I finding? So some of the results. This is basically one of the main things, what I was hoping for, and it seems to produce really nicely, I think, is going to say quasi-periodicity. You get lots of structures which have almost these repeating motifs. So instead, they're not completely regular. And I think there's something about being human psychology that what we're interested in and really attuned to are things where if it's completely regular, it becomes a bit boring. If it's completely random, it hasn't got any structure or meaning. But by being quasi-periodic, and I think these sirens almost like naturally will tend to produce quasi-periodic forms. Hopefully that's something which we're just naturally attuned to. So hopefully it's almost like a human aesthetically interesting palette of possibilities. So yeah, it does seem to produce this quasi-periodicity, almost repeating motifs, but nothing ever is really quite repeating. And that's maybe then something you can play with. It's almost like how much quasi-periodicity. You get like some things which are much more random, some things much more regular. Also, you can make them dynamic, almost like instead of just having like an X, Y, and Z position in space, just have a fourth input, time. It's now made it naturally a dynamic playing, changing over time form. This is like, basically a siren producing a 3D structure just with, just one extra input for time. Also, you can do color. So it's like instead of just having one output for the field values for like, where I want the geometry to be, I can have some additional outputs, say red, green, and blue color outputs. And those all come from the same sort of neural network. It's just, different final blending of those values from the neural network. So hopefully you end up with colors which are also quasi-periodic and dynamic and relating to the structure. So almost a very natural, hopeful connection between the color and the actual form of the surface. So hopefully, so those examples seem, yeah, some really quite happy. I'm having fun with this. It's an interesting, rich palette of possibilities. One thing I'm just going to add, so compared with when the paper, I'm still working on this, so the 5 minutes late. So the paper I I showed stuff basically using marching cubes. I'm actually now worked on making actually a much better way of rendering. So this isn't real time. This is a slower way of rendering, but is much more memory efficient using what's called trilinear surfaces. So it allows it to work out effectively the shading, the normals much better, and also uses a lot less memory. So basically that's gone from, that's how I had it when I sort of submitted the paper for EVA. I've now got the rendering looking like this, almost like a lot more detail, a lot better sort of surface shape, a lot more sort of definition. So I'm going to quickly skip through the conclusion because I want to get on, actually hand out glasses. Hand these around quickly around the room. So, you know, obviously, I think it works. You can generate these 3D forms. You can do them interactively, which has potential for doing things like live driving it off, you know, music and things like that for interaction. One thing I've been doing some tests with is I've been doing some stuff at down Plymouth University, including 3D printing and ceramics and stuff like that, which I'm not talking about at all today. But one thing they got at Plymouth is full domes. So like, you know, sort of 360-degree sort of like environment. So I've been playing with doing things in 3D stereo inside a full dome. Which way around? You'll soon find out. I think it's red to your left, I think, right? So try and do 3D stereo in a full dome, which I've been testing using virtual reality, and hope it looks like it's really it's like crazy cavern of 3-dimensional depth around you. So I'm going to now just quickly go, because I don't have much time, so go to the video. So this should be, hopefully you should be able to see this in stereo. Oh, it's not playing very well, but you can see it though. Okay, let's just go to it again and play. Okay, I thought it was playing back, not nearly as well. If you go to YouTube, search Andy Lomas, SIRENs, 3D anaglyph, you'll see this much better on YouTube. But hopefully you're starting to see there's a real, I think, strong sense of 3-dimensional depth that you get, and this is just doing like these transitions between the different parameters in the space of possibilities with the SIRENs. I guess we could ask questions while I carry on playing this back.
Yeah, definitely.
So you see it's all audio synthesis being used to generate crazy 3D form. No, I don't, but it's something I'm thinking of trying. Actually, I do have audio for this, but it's actually just a piece of music by Max Cooper, who's a musician I work with quite a lot. So it's not actually directly relating, it's just like, oh, that sounds nice and cool with those visuals, but it's not driven off the same thing. But absolutely, that's one thing I'm thinking about is, like I'm driving RGB color off the same Siren network, I could also just try driving audio, you know, driving something that has much higher time frequency, things like that. So yeah, I haven't tried that yet, but I'm thinking about that.
It would be interesting to also add rhythm to it. So not only sound. The DX7 is primarily a sound machine, I remember. But rhythm is something that is so important for music as the sound. And the pictures we see are also rather rhythm than sound, I would say. And
so
the pseudo-periodicity is something like jazz opening against classic hard, I don't know in English. So being precise in playing or being free jazz sort of playing. That's what you said about psychology in the perception of images.
Yeah.
And this is why jazz is sort of more attractive to people who are educated in music than whatever, Bach or so. That would be interesting.
Yeah, I think that would be really interesting. And actually one of the cool things about the sirens, like the work by Vincent Sitzman et al., is they showing almost like you can encode both sound, so I guess more like the classic audio synthesis from the DX7, and also whole pieces of music where it is more rhythm and things like that. I mean, almost the idea that there's probably potentially quasi-periodicity both on the individual waveform for the sound and also over a long time. And that could come naturally from this sort of network where, I mean, I've got thoughts about how that's doing. You do that. Things like you want to be sampling time effectively very fast for producing an audio sound. And you could also be sampling slowly to be changing rhythm. So it's almost the slow change of changing parameters. I think both could be driven off the same siren network. Actually, it's a, you know, I mean, it's almost the Sitzman have already shown that actually works. You can efficiently encode both, you know, individual audio spectrum and whole rhythm
so you would say
with these networks.
The transition between the micro appearance and the overall total shape of the one thing you showed was not a ball, it was a shape, an individual shape, is a question of frequency coming in the music sense from the sound over rhythm to the entire piece. That's the analogy?
Probably, I think one of the analogies for, I think most of these visual structures are more like sound synthesis, I think, than rhythm synthesis. What I'm sort of saying is I think that one of these naturally lends itself to is almost like multi-resolution, right? So on visual things is, you know, that there could be, you know, you pull back further and further and then there's like different patterns and different modalities as you look at it on a larger and larger scale. And I think the same could translate potentially interestingly into sound. So I think that Sitzman and all show that you can code music well, both almost like overall rhythm and individual sound structure. Okay, what does this naturally do? You know, rather than just encoding a known piece of music, I think could be interesting. Where it's almost like, as I say, I think our perception hears tone and it hears rhythm. Can we do both?
Sort of related to this as well, but how would you ideally want people to kind of experience this kind of thing? Like, would it be a sort of audio-visual composition in like a full dome, or like what's your kind of ideal?
I'm still working on this as almost like ingredients. I'm sort of, it's the full dome experience. I think is quite interesting. So I actually just submitted it to the Full Dome UK to hopefully get in for this year. You know, the sense of three-dimensional huge cavern you're in that you get from it being in a full dome with anaglyph, I think is really quite interesting. Even as in VR, it's almost like in VR, just taking what the experience would be in the full dome, and actually, you know, even though it's not maybe using everything that VR could do, actually maybe that's quite cool. Actually, it's rather than being the traditional VR-like experience, it is this, you know, really a richly dimensioned cavern that you're in. And then that obviously has the connections you can have audio driving into that. The other thing I'm thinking about is inverting that completely the other way of almost like what is the experience in a more completely virtual environment of sculpture? That's something I'm interested in exploring further. And I feel this is a potential ingredient to feed into that. I guess that's more my, yeah.
I'm wondering how this would look, because you've sort of shown them as kind of like balls and things, but I kind of want to see them inside out and be inside them as kind of tunnels and things. So I guess the full dome and the kind of things.
Well, that's literally what I've done. I'm actually rendering the full dome by actually having a ball and then a lens that's actually rendering into it. So effectively, I'm wrapping it inside out as it renders it. So it's actually, the environment is actually just a sphere originally, or a ball-like structure, which then is being, wrapped inside out as it renders.
Thank you so much, Andy. I think we'll have to wrap it up there, but fascinating as ever. Thank you.
Thank you, everybody.
invite Florent to the